Direct metal laser sintering, also known as DMLS, is an additive manufacturing technology that creates metal parts directly from 3D CAD data without the need for tooling. DMLS utilizes a variety of metal and alloy materials, such as stainless steel, cobalt chrome, and Inconel, to create strong, durable parts and prototypes. DMLS is an excellent choice for functional metal prototypes, high-temperature applications, and end-use parts. The DMLS process begins in the same fashion as other layer additive manufacturing technologies. A program takes 3D CAD data and mathematically slices it into 2D cross-sections. Each of these sections will act as a blueprint, telling the DMLS machine exactly where to sinter the metal material. The data is then transferred to the DMLS equipment. A recoater assembly pushes powdered metal material from the powder supply to create a uniform layer over the base plate. A laser then draws a 2D cross-section on the surface of the build material, heating and fusing the material. Once a single layer is complete, the base plate is lowered just enough to make room for the next layer. More material is raised from the cartridge and recoated evenly upon the previously sintered layer. The DMLS machine continues to sinter layer upon layer, building from the bottom up. As the part is built, support structures are added to give supplemental strength to fine features and overhanging surfaces. The completed part is then removed from the base plate and treated with an age-hardening heat process to further harden the part. Any support structures are also removed at this time. With numerous surface treatment and hand polishing options available through service providers, DMLS parts can be used in highly cosmetic applications. Typical uses for DMLS include tools and manufacturing aids, small integrated structures, dental components, surgical implants, and aerospace parts.